Hi, next we are going to discuss our second question. Our first problem is an application of mean value theorem, and second problem it is the application of our next theorem, that is Rolle's theorem. And what do you mean by Rolle's theorem? A Rolle's theorem states that if a function f of x is continuous in the range a less than or equal to x less than or equal to c and is differentiable in the range a less than x less than c, then in between this a and c we can find a point b such that, and if this f of a equal to f of c, then f dash of b equal to 0. Or in another way we can say that if a function f of x has certain roots, let it be a c, then we can find out the root of his derivative of that function. That is, we can find out the root of the function f dash of x in between the roots of the function f of x. Okay, got it? So, can we continue? I repeat, if a function f of x has a root, then in between we can find out its derivative's root. That is simply mean value Rolle's theorem. Okay. So, we move to our second question. Our second question has three subdivisions. So, let me tell you the question clearly. Use Rolle's theorem to deduce that if the equation f of x is equal to 0 has a repeated root x1, then x1 is also a root of the equation f dash of x is equal to 0. So, given that we have to solve these problems by applying Rolle's theorem. And what are the conditions given by in this question? The function, our function f of x is equal to 0 has a repeated root. That means it has equal roots. Repeated root means it is a condition of, it is the situation of having equal roots. So, our function f of x is equal to 0 has repeated roots. Then that repeated root become the root of what function? The derivative of our function, that is f dash of x is equal to 0. So, if x1 is a repeated root of f of x is equal to 0, then that x1 will be a root of f dash of x is equal to 0. Okay. This is the explanation of your question. And the first subdivision, what is that? Apply this result to the standard equation ax square plus bx plus c equal to 0 to show that a necessary and sufficient condition for equal root is b square is equal to 4ac. So, we all know that how to find out the roots of a quadratic equation. Here, we have to deduce one. What was that? We have to show that a necessary and sufficient condition for equal roots of a quadratic equation is b square is equal to 4ac. We are all now familiar with this result. But using Rolle's theorem, we have to show this result. Okay. By using Rolle's theorem, we have to show that the necessary and sufficient condition of a quadratic equation of having equal roots is b square is equal to 4ac. Okay. Now a question, there is a hint given by that. Whatever will be the function, that function has a repeated root. That repeated root will be a root of f dash of x is equal to 0. That is the hint given by our question. So, in order to solve the first subdivision, we can use this result as well as our Rolle's theorem. Okay. So, first the form of quadratic equation is x square plus bx plus c equal to 0. So, I took x square plus bx plus c is equal to 0 as f of x. Okay. Then, we know that the equation of solving this, or the equation to find out the root of quadratic equation is what? X is equal to minus b plus or minus root b square minus 4ac by 2a. Right? Then I mark f of x as equation number 1 and I mark the second equation x is equal to minus b plus or minus root b square minus 4ac by 2a as equation 2. Okay. Then we have to, what is our aim? What we have to show? We have to show that the necessary and sufficient condition for equal roots is b square is equal to 4ac. Okay, here in the second equation, this part b square minus 4ac is called discriminant. We all know that, right? Then our question gives that f of x is equal to 0 has a repeated root. What is f of x? Ax square plus bx plus c equal to 0, right? That is ax square plus bx is equal to 0 has a repeated root. So, we know that this is a quadratic equation. Quadratic equation means how many roots it have? It has at most, or it has maximum how many roots? It has 2 roots, right? In our question gives that f of x is equal to 0 always have what kind of roots? Repeated roots or equal roots. So, we can take the roots of this equation as, we take the roots of this equation as x1 and x2. But in our question gives that every time our f of x equal to 0 has what kind of roots? Equal roots. So, we can conclude that this x1 must be equal to what? X2. Okay. And the next equation 2 gives the way of find out the roots of the formula to find out the roots of our quadratic equation. Okay, that I mark equation 2. Then it's only at the beginning we have to show that the necessary and sufficient condition for equal roots. But in the mean value, in the Rolle's theorem says that in between roots of a function you can find out at least one roots of its derivative. So in order to find out the roots of derivative, we have to find out the derivative. What is f of x? Ax square plus bx plus c. Then we have to find out what? F dash of x. If f of x is equal to x square plus bx plus c, then f dash of x is equal to 2x plus b, right? Okay. Then we have to find out the roots of f dash of x. F dash of x is equal to 2x plus b. We know that the degree of this equation is 1. That is, it is a linear equation. So, in order to find out the root, we have to put the right side is equal to 0. Where f dash of x is equal to 2x plus b. And in order to find out its roots, in order to find out the root of f dash of x is equal to 0, we have to put the right side. The right side is what? 2x plus b, which is equal to 0. That is 2x plus b equal to 0. If 2x plus b equal to 0, then what is 2x? 2x is equal to minus b. And what is x? X is equal to minus b by 2a. Right? So, again, we have two main hints in our hand. One is our mean value theorem. Mean value theorem tells us that the function in between two roots of function, we can find at least one roots of its derivative of function. Okay. And another hint that the function, if function has a repeated root or an equal root, that equal root will be a root of f dash of x. Here we got a root of f dash of x. And what was that root? Minus b by 2a. So, according to our second hint, this root of f dash of x is equal to 0. And what is that? X is equal to minus b by 2a. And that become one of the roots of f of x is equal to 0. And what is f of x is equal to 0? What is that? X square plus bx plus c equal to 0. Okay. So, we got, and we finally conclude that. We get our conclusion now. Okay. This is the root of, here we got the root of f dash of x is equal to 0 as minus b by 2a, and this minus b by 2a is also a root of f of x is equal to 0. That is x square plus bx plus c is equal to 0. But x square plus bx plus c has two roots, and that two roots are equal. Now we got the form of the roots, and what was that form, or what was that root? Minus b by 2a, right? Then the roots of f of x is equal to 0 is, and f of x is equal to 0 has two roots, x1 and x2, and x1 is equal to x2. So, x1 is equal to x2 is equal to minus b by 2a. Okay. If x, you look at the second equation. If x is equal to minus b by 2a, then what is root b square minus 4ac? If x is equal to minus b by 2a, then what is root b square minus 2a, b square minus 4ac here? Then it must be 0. That is root b square minus 4ac equal to 0. If root b square minus 4ac equal to 0, then b square minus 4ac is equal to what? 0. Okay. Only the root of 0 is 0. So, root b square minus 4 is equal to 0 means b square minus 4 is equal to 0. B square minus 4 is equal to 0 means that what? B square minus 4 is equal to, b square is equal to 4ac. Okay. That is, finally we got that our quadratic equation ax square plus bx plus c has two roots, and those two roots are equal, and those two roots are of the form minus b by 2a. Then we look at our second equation, x is equal to minus b plus or minus root b square minus 4ac by 2a. If two roots are of the form minus b by 2a, then b square minus 4ac must be 0. That is, b square is equal to 4ac. That is the necessary and sufficient condition for a quadratic equation having equal roots or repeated roots is b square is equal to 4ac. Got it? Got it? So, this way we can solve our first subdivision, and it is really easy. We can solve each and every problem has certain hints provided in our question. So, we can make use of those hints in order to solve each and every problems. Okay. So, the second question B. Let me read the question first. The question is, find all the roots of f of x is equal to x cube plus 4x square minus 3x minus 18 equal to 0. Given that one of them is a repeated root. Here our main job or our main aim is to solve the polynomial x cube plus 4x square minus 3x minus 18 is equal to 0. Or we have to find out the roots of the polynomial. We have to find out all roots of the polynomial x cube plus 4x square minus 3x minus 18 equal to 0. So, in our question it is given that it's a cubic polynomial. Its highest degree is 3. So, it's a cubic polynomial. So, how many roots are possible? It has at most 3 roots, or it has how many roots? Maximum 3 roots. Okay. So, we have to find out those 3 roots, and there is a hint provided in our question, and what was that? And it is one of the roots of this f of x is repeated roots. That means if this f of x has 3 roots, let that roots be x1, x2 and x3. Then 2 roots will be equal. Repeated root means one of the roots is repeated, means 2 roots are same. So x1, x2, among x1, x2, x3, 2 are same. Okay. So let me solve. So how to solve this problem? In order to solve this problem, we can use Rolle's theorem, as well as there is a hint given by in our question that one of the repeated roots of f of x is equal to 0 is also a root of f dash of x is equal to 0. Okay. So, did you know how to solve a cubic equation or a cubic polynomial? If you don't know, let us take a look here. Okay. So, first we have to find, here I already stated the Rolle's theorem. Okay, if you want you can read. Okay, I already explained the beginning, so already explained some things, Rolle's theorem, questions. So better we can continue to find out the roots of f of x is equal to 0, right? So, and moving to I have to find out the roots of f of x is equal to 0. Okay. So, what is f of x? X cube plus 4x square plus 3x minus 18 is equal to 0. So, this is a cubic polynomial. So, it has at most 3 roots, 3 distinct roots, and the roots are 3 roots may not be distinct. It may be distinct or may not be distinct. But here there is no possibility of these 3 roots become distinct, because it is given that one of the roots of this f of x is equal to 0 is repeated. So, either 2 roots are same and the third one is different, distinct from the first 2. Okay. So, in order to find out the root, we have to put some values of x, and we have to put some values of x in f of x. Okay. First we write f of x, and f of x is equal to x cube plus 4x square minus 3x minus 18. Okay. And how? Okay, let me, I will explain it later. Now, when I put x is equal to 1 in our f of x, then what it will become? Then f of 1 is equal to 1 cube plus 4 into 1 square minus 3 into 1 minus 80. And definitely it is not equal to 0. Okay, what means it is equal to 0? And what do you mean by f of x is equal to 0? And what do you mean by a root? What do you mean by a root? Tell me, what do you mean by a root? A root means when consider a function f of x is equal to 0. If x is a root means when we substitute in x in that equation, the right side of that equation becomes what? 0. Or the right hand side and left hand side will be 0. Okay. Or when we substitute x in f of x, then the equation satisfies, or the left hand side is equal to right hand side. Okay, this is the definition of root. So here our equation is f of x is equal to x cube plus 4x square minus 3x minus 18. In order to find out the roots, I have to substitute several values for x. First I substitute x is equal to 1, but f of 1 not equal to 0. Then 1 cannot be root of f of x is equal to 0. Then I substitute x is equal to 2, and finally I got f of 2 equal to 0. There are some calculations. It is very easy. Next, I check f of minus 2, whether f of minus 2 is 0 or not, but f of minus 2 is not equal to 0. So, minus 2 is not a root, 1 is not a root, but 2 is a root of this f of x is equal to 0, right? Then again, I am going to check 3 is, whether 3 is a root of f of x is equal to 0 or not. Okay, so consider f of 3. How to find out f of 3? You have to put x is equal to 3 in f of x. Okay. So your f of 3 become f of 3 is equal to 3 cube plus 4 into 3 square minus 3 into 3 minus 18, and which is also not equal to 0. Thus 3 is not a 0 of f of x is equal to 0. Again I put x is equal to minus 3. Then our equation becomes what? Minus 3 cube plus 4 into minus 3 square minus 3 into minus 3 minus 18. Finally I got f of minus 3 equal to 0. So this f of, in our question it is given that we have to find out all the roots of this f of x is equal to 0, but given that one of the roots of this f of x is equal to 0 has 3 roots, and among those roots, two of them are equal. Okay, here we find out 2 roots of this f of x is equal to 0, and what was those roots? One is what? One of the roots is what? One of the roots is 2, and another one is what? Minus 3. Then we have to find out one more root. But there is a hint in our question that among 3 roots, 2 are same. So either now we got 2 roots, 2 and minus 3. Either 2 is repeating or minus 3 is repeating. Okay. We don't know which one is repeating. In order to get a confirmation, or in order to get a clarity, we are going to apply which theorem? Rolle's theorem. Okay, what is Rolle's theorem? Rolle's theorem says that in between a root of function, we can find at least one root of its derivative. So we have next we are going to find out the roots of the derivative of f of x. And f of x is given by x cube plus 4x square minus 3x minus 18, right? And what is f dash of x? F dash of x is equal to 3x square. The derivative of x cube is 3x square, and the derivative of x square is 2x. So 4 into 2x square is 8x. Okay, 4 into 2x is 8x, and derivative of minus 3x is minus 3, and derivatives of minus 18 is a constant. The derivative of a constant function is 0. So we got f dash of x is equal to 3x square plus 8x minus 3. And this is a quadratic equation. F dash of x is equal to, in order to, what is our f dash of x? 3x square plus 8x minus 3, right? How to find out its root? We have to equate the right hand side to 0. That is 3x square plus 8x minus 3 equal to 0. Now this is a quadratic equation. How many roots it have? 2 roots. And what was the formula to find out the roots? X is equal to minus b plus or minus root b square minus 4ac by 2a, right? And here a is equal to 3, b is equal to 8, and c is equal to minus 3. Put all the values of a, b and c in the formula. X is equal to minus b plus or minus root b square minus 4ac by 2a. Okay. Then you can find out 2 roots, and the 2 roots are x is equal to 1 by 3 and x is equal to minus 3. Okay. Again, I repeat the question. Again, I repeat the hint given by our question. And what was that? F of x is equal to 0 has repeated root. That repeated root become, or that repeated root is a root of f dash of x is equal to 0. Here f dash of x is equal to 0 has two roots, 1 by 3, x is equal to minus 3. Remember, this x is equal to minus 3 is also a root of what? F of x is equal to 0. Now we got f dash of x is equal to 0 has two roots, and what was those roots? X is equal to 1 by 3 and x is equal to minus 3. And remember here, this x is equal to minus 3 is also a root of f of x is equal to 0. So this minus 3 will be a repeated root of f of x is equal to 0. So all the roots of f of x is equal to 0 are what? Minus 3, 2. That is, two roots are repeating, and those are what? Minus 3, and the other root is 2. Okay, this way we can solve the next problem also. Got it? Hope you understand this problem. Thank you.